All right, my peeps, welcome back. This is Coach Lowe coming to you with, and this is totally not 7.3 because this year we sort of changed things up and it's 3.2. All right, so hang on, let me get this thing writing. So, bam, you're out of here. 3.2. Number streaks, hypothesis testing. Here we go. All right, so there are definitely times when it probably will be a little awkward to use the longer streak. Um, I like this good example right here. If a baseball team had 5 wins, 5 losses, it probably wouldn't be the most useful measure to do the longer streak. So that's why it's going to bring up, well, that's why we're going to bring up our next test statistic, which is the number of streaks, not the longer streak, but how many streaks you got. So we got some guidelines right here. If there are less than 50 attempts, we're going to use 3 or more. We're going to go 50, 100 attempts. We're going 4 or more. With 100 attempts or more, we're going with streaks of 5 or more. Okay, general guidelines. So here we go, hypothesis for number of streaks. So we got the null alternative, and you'll see them worded this way a lot. The outcomes of the games or the attempts were, and the word that we like to use here is independent. Okay, so for streaks, this is like us saying from before a certain player had the same ability. All right, now with streaks, we're going to use a different lingo. We're going to say the outcomes were independent. And then for the alternative, you would put something like the team or the person was or were, and then you're going to put basically they were a streaky player. Sometimes you'll see people write they had the hot hand, so either one of those is fine here. Okay. In fact, I'll just put that in there. Had the hot hand, whoever that was. Okay, that means they were definitely streaky. So for the Orioles, 98, here we go. We will use the number of streaks of 5 in a row for a test statistic. If you're thinking about the null, you would just say something real simple like the Orioles games, sounds weird, were independent. And believe me, I just keep these as simple as I can. Okay. Then for the high, you're going to say the Orioles were a streaky team, specifically for that season. Okay, so that's your null and your alternative hypothesis. And then here comes the data. So what you see here are 79 wins, 83 losses, grand total of 162 games for baseball. And since you had 162 games, that's well over 100. So you would look for any streak of 5 or more. So right here, you got definitely a streak of 5 or more wins. And you also count the losses, so definitely 5 or more, 5 or more, 5 or more. So we're going to count up how many of these streaks we had. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's what you're thinking about. This is going to be your test statistic. All right, that is none, which makes it short and sweet. Down here, I like what they're saying here. Good example of doing the simulations, caveman style with the cards. If you wanted to simulate this, you would basically take 162 total cards and count up how many wins they got, which is nice. They're telling you you would put 79 W's on those cards. You'd put 83 losses on those cards. Again, for a grand total of 162. You're going to shuffle them up as good as you can. Then you're going to lay them down. And then once you lay them down, you're going to start counting again how many streaks of 5 or more you got. Okay, and that would represent one simulation of 162 games. Okay, moving on here. So now we got the dot plot. So determine the p-value. So our test statistic was at 9, which is going to be, and always double check, make sure you're in the right place with the graph. 9 goes right here. So we're going to be counting all the dots that are on this line or to the right, which means we got 2 dots, which they just said up there. All right, so and only 2 times in those 100 simulations did we get a streak, or did we get 9 streaks of 5 or more. So definitely that is a little more special. So here we go. Interpret. Make sure you hit all the fine points here. You're going to start off by saying, assuming, let me write this neat. And if you go back, we used to say assuming they had the same ability. Here we're going to say assuming the games are independent of each other. Just leave it off. Assuming the games are independent events. Go right into it. There is a and 2, so that's 2% chance of getting whatever the test statistic was of getting 9 streaks of 5 or more. And then top it off with by random chance. Okay, sort of didn't finish it up here, but yeah, we have 2 dots, assuming there are 100 dots up here, which I believe there are. Yeah, 2 divided by 100 would give you 0.02 or 2%. This would be your p-value. Okay. All right, so can you make a good conclusion here? Definitely, here we go. Since your p-value is 0.02, so 0.02 is less than 0.05, that means, said it wrong. That means that random chance is not plausible. Not a plausible explanation. And therefore, and here's where you choose which hypothesis you go for. So since our p is 0.02, random chance is not possible, therefore, you say the Orioles, and you go with the ha, were a streaky team. Voila. All right, moving on. We go through more slides. Oh, look at that hair. So here we go. Mario Lemieux, Pittsburgh. During 88-89 season, he led the NHL with 85 goals. Demonstrated that he definitely had a capacity, the ability to score. So here we go. In order, these are the outcomes for each of the 76 games. Let's see here. Describe what it means to be a streaky player. That means Mario Lemieux had a greater ability to score in a game following, how do I finish that? Following a game in which he scored. Okay, so that's what it means to be a streaky player for him in this case. So state the hypothesis. Here we go. So the null, we would say that Mario Lemieux's games were independent events, definitely independent. And then for the ha, we're going to say that Mario Lemieux was streaky. Keeping it real simple again. Or you could say that Mario Lemieux had a hot hand. Okay. All right. So how many streaks of 4 in a row did he have, and why are we going 4 in a row? Since there's 76, that's between 50 and 100. So we're definitely looking for streaks of 4. So here's where you got to make sure you slow down and think about this. So that's 1 streak of 4 more. And make sure you're looking at the N's as well as the Y's. 2, 1, 2, 3, 4. So there's another streak. We're looking for streaks of 4 or more. So 4, nope, nope. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 1, 2, 3, 1, 1, 2, 3, 1, 2, 3, 4. Sneaking in right there. Which means we got 1, we got 2, we got 3, we got 4, we got 5 streaks. Okay, so we had 5 streaks of 4 or more. Okay. All right, here we go. Now this page, I'm just going to explain it and let that go. If you were doing the simulation of this, if you remember back, there were 76 total games, so you want 76 cards. Well, maybe I will do this. 76 cards. Then you'd have to count up how many yays and nays are in here. Did they say that? And they did not, which is a bummer for y'all because I'm not about to count those up. So here we go, 76 cards. Then you're going to count up how many were yays. You need that number of yays, and you need the number of nays. And again, make sure it adds up to be 76. Then you're going to shuffle, and then you're going to distribute randomly. And then, here we go, count the number of streaks of 4 or more. And then, of course, that number is going to represent a dot on the dot plot. And then, of course, you repeat because we like to law large numbers in our favor. So we want as much data as we can. So, all right, there it goes. So dot plot below shows results of 100 simulated seasons. Assuming the outcomes were independent, here we go, use the, okay. So we're going to estimate and interpret the p-value. So what do we get? We get 5. We got 5 streaks of 4 plus. So p, all right, here we go. Test statistic was 5, which is going to be, all right, here's the bad news, people. You're right here. So there's 5 streaks of 4 or more. And like I said, the bad news is you got to start counting dots. Now, luckily for y'all, I counted the dots over here earlier, and I think there was 37, which means over here, this should be 63 to make out 100. So that means 63 divided by 100. So we're looking at 0.63 or 63% for our p-value. All right, so here we go. Estimate and interpret p-value. So we get p is going to be 63% or 0.63. All right, so let's do this. Assuming the games are independent of each other, there is a, here comes the p-value, 63% chance of getting 5 streaks of 4 or more, or 4 plus, by random chance. Bam. Okay, so there's your interpret. All right, so based on the p-value, is there convincing evidence? So there we go. Since p is greater than, you know what, hang on a second, I don't like doing that. I like being specific. Okay, since our p-value, so since 0.63 is greater than 0.05, random chance is still very much possible. Therefore, you have to go back, support the null hypothesis, in which case you would say Mario Lemieux's games attempts were independent. In other words, nothing to see here. Okay? And think about it, just in general. If you're over here with your test statistic, there's a lot of dots over here. Okay? And that means that it's going to be real easy to simulate 5 games of 4 or more. So in order to ever support the HA, the p-value's got to be very low, which means you're looking for the test statistic, which is going to be farther to the right. Like you want it to be like right in here where you got 2 little dots right here, which means you'd have 2%. That's when it becomes more special.